Hello, Cormac Allen here again. In this presentation I will take you through some samples of work from second year of the TU831 Architectural Technology programme. In second year, the student is introduced to timber and steel technologies in semester 1 and concrete and NZ technologies in semester 2. The first major project of semester 1 is a multi-storey timber frame residential building. Semester 1 commences with a project which focuses on real-life examples of building defects, followed by a project exploring the use of passive house technologies in case study buildings. This prepares the students for the timber frame residential building project. This project explores mass-produced residential timber construction and the use of claddings and coverings. As with the house project in first year, the design is explored using the sketch design process, following which the Revit BIM model is developed. The drawings are then extracted from the BIM model as PDF files which can be viewed digitally or printed onto paper. This is a general arrangement drawing showing the ground and first floor plans of the building. Like the house drawings of the previous presentation, this includes grid lines, section lines, dimensions and notation describing key elements. The building is multi-unit and timber framed, making it more complex than the single house project of first year. This is the general arrangement drawing showing the second floor and roof plans of the building. As a multi-storey residential building, it has more onerous fire safety provisions which must be understood and incorporated into the design. These are the general arrangement elevation drawings which have been set up to print at a scale of 1:50. Again, you can see the use of grid lines and level lines which confirm dimensions and relate back to the GA plans following industry conventions. This requires a certain rigour, which is very much valued by our employers, who rely on our graduates to enter the jobs market with industry standard skills. The drawing on the left shows two 1:50 cross sections. The detailed drawing on the right shows more detail and explains the overall construction technologies used in the building. As with the first year house project, note the insulation which runs continuously under the floor, up through the walls and across the roof, providing an unbroken thermal envelope. Note also the insulation in the first floor. This is required for the purpose of fire safety rather than thermal insulation and needs to be considered differently. The thermal insulation of the building needs to comply with Part L of the building regulations, while the fire safety aspects need to comply with Part B of the building regulations. These are detailed drawings of various party wall conditions at a scale of 1:5. In these drawings, the insulation in the party wall, that is the wall that separates the two dwellings, needs to comply with both Part L and Part B of the building regulations. This is a very important responsibility and is at the heart of what the architectural technologist is responsible for in the technical design process. These are more detailed drawings, this time of the external walls. These include the jamb, head and sill details for the window openings at a scale of 1:5. All of these have been teased out in the sketch design process prior to digital modelling. And these are further detailed drawings, this time looking at variations in the external cladding systems used in the wall assembly. And finally, here is the site plan, showing the site in context and indicating features such as car parking, drainage layouts and connections to the public sewers on the adjacent road. The second major project of semester 1 is the medium span non-residential steel framed building. As with other projects, the building is explored using the sketch design process, following which the Revit BIM model is developed. Working drawings are then extracted from the BIM model. This can be either as PDF files which can be viewed digitally or as drawings printed on paper. This is a general arrangement or GA drawing showing the ground and first floor plans of the steel framed building. The building design is kept very simple so that the students can fully investigate and understand the characteristics of steel construction technologies. This is a GA drawing showing fire escape strategies as part of a building regulation compliance process. This kind of building is required to comply with Part B of the building regulations, which provides for fire safety and allows the occupants escape from the building in the event of a fire. These are the general arrangement elevation and section drawings. In this instance, these have been set up to print at a scale of 1:100. You can see the use of grid lines and level lines which confirm dimensions and relate back to the GA plans. Even at this small scale, it is still clear what is going on. This is very good draftsmanship. And this is a section and elevation study at a scale of 1:20. You can see how the plan and section project from and relate to the elevation. As with all buildings, there is an emphasis on thermal performance and the need for a continuous, unbroken line of insulation in the walls, floor and roof. This is called the thermal envelope. You can see from this drawing that this student really knows their stuff. And again, while the 1:20 sections describe the overall construction, more detailed drawings are required to describe each part of the building. These are detailed drawings of the walls, floors, window openings and roof, all at a scale of 1:5. And here are drawings describing the stair, which is designed to be constructed using steel technologies. Stairs need to comply with Part B, Part K and Part M of the building regulations. Part B relates to fire safety, Part K relates to stairs, and Part M relates to universal access. These three parts of the building regulations combine to ensure that people can get into, around, and out of a building safely and with due regard to the principles of universal access. All of this requires careful consideration and needs to be thought out with regard to three-dimensional realities. It's very skillful work. Here is the site plan, setting the building in its context, including access roads, footpaths, parking bays and building services such as drainage and water supply. And here is the building information model of the building, from which all these drawings are extracted. The BIM model contains all the information needed to generate these 2D drawings, as well as schedules and interior and exterior 3D renderings such as these. We always say to students that the digital model is only as intelligent as the information it is given, and that's the job of the architectural technologist. The focus of semester 2 in second year is a multi-storey concrete framed, nearly zero energy building. As with other projects, the design is initially explored using the esquisse sketch design process. As each year progresses, the depth of the esquisse investigation increases. Each aspect of the building is systematically explored, from structure to energy performance to building services to accessibility and so on. And as the esquisse progresses, the Revit BIM model is developed in parallel, one informing the other in the three-dimensional investigation of the building. The drawings are then extracted from the BIM model as PDF files to be viewed digitally or printed onto paper. This is a general arrangement drawing showing the basement plan of the building. The red lines indicate the provisions for emergency escape in the event of fire as required by Part B of the building regulations. Note also the provision for accessible car parking and refuges for wheelchair users in the staircases as required by Parts B and M of the building regulations. This is the general arrangement ground floor plan of the building, showing grid lines, dimensions and general notation. And this is the general arrangement second floor plan of the building. The drawing shows the provisions for emergency escape in the event of fire. Note also the layout of the toilets, which have been worked out in all details. And this is the general arrangement for the third floor and roof terrace plan. This sectional study of the building is at a scale of 1:50, with each junction and detail shown. As with other sections, This drawing shows the continuous line of insulation in the floor, roofs and walls, providing the building with a continuous thermal envelope for energy performance. The sectional details are further developed at a scale of 1:10. These include further information including cladding panels, raised floors and rainwater drainage. Further, larger scale details at 1:2 allow for the exploration and resolution of issues such as building air tightness, which is a fundamental requirement of thermal performance. This is a study of the precast concrete wall cladding panels. You can see the consideration given to the three-dimensional shapes, how the panels turn the corners of the building, and down to the details of the fixing brackets which are used to secure the panels to the building structure. And this is a section drawing looking at how the precast concrete wall cladding panels are set in place and supported on the concrete frame. And while the drawings describe the construction technologies, the students are required to examine the thermal performance characteristics and carry out U-value calculations. As I have said, all this information is contained as data within the BIM model, which is used to generate these 2D and 3D technical drawings and details. The BIM model is also used to generate three-dimensional studies, including interior and exterior views of the building. These are really important and useful tools which enable the student to understand the visual end result of their technical design decisions, but also serve to explain complex buildings in a really accessible way. So that completes this brief outline of the work of the second year of TU831 Architectural Technology. I hope you found it useful. My next presentation will look at the work of third year students, showing how the skills learnt in second year are further developed on what we call multi-cell buildings using engineered timber technologies.